All right, so for lesson 5, we're going to be talking about polynomials and their graphs. So a polynomial is one or multiple terms added or subtracted. So the definition of a degree is the highest exponent if you're in standard form, and you add the exponents for factored form. It's not really a definition, but it's just kind of how we find it. So where can we find the leading coefficient? And that would be in front of the highest exponent. All right, so looking at this first example, we're looking for the highest degree because this is in standard form. So if we look, we have a degree of 2, 9, and then this would be 1. So the highest exponent would be 9, so the degree would be 9. And if we're looking for the leading coefficient, we look in front of that x to the 9th. So our leading coefficient is 7. And really what we're concerned about with leading coefficients is if it's positive or negative. So looking at number 2, we have 6, 1, and 3. So 6 would be our highest, so our degree is 6. And our leading coefficient, it would be -1. So it would be negative. All right, so turning points. So turning points are the max and min points on a curve. A polynomial can have at most one less turning point than its degree. End behavior is determined by the degree of the polynomial and the sign of the leading coefficient. All right, so if we have an even degree, that means the ends point in the same direction. And depending upon the leading coefficient, if the leading coefficient is positive, then both ends point up. So it's going to look like this on your graph. And if the leading coefficient is negative, then the ends point down. For an odd function, the endpoints go in opposite directions. And if the leading coefficient is positive, the right end points up. So if the right end points up, then we know the left end has to go down. And if we have negative leading coefficient, then it's going to go down. So the right end is going down while the left end would go up. All right, so mathematical terminology for our end behavior. So as x approaches negative infinity, so this is saying that as we approach the left side of our graph, f of x is either going to approach infinity, which means up, or negative infinity, which means it's going down. And then for the right end, if we approach positive infinity, it means we're moving to the right. F of x approaches positive infinity, again means up, and negative infinity means down. All right, so looking at a graph, we need to figure out a lot of information just from all this knowledge that we just talked about. So looking at number 3, we're looking for the degree. The degree is going to be the highest exponent because we're in standard form. So in this case, it would be 2. In front of that degree, we just have a 1. So our leading coefficient is positive. So turning points, we're looking at how many times does our graph switch directions. So that happens once, and it happens at the minimum. So we'd have 1 turning point. And then for our end behavior, as x approaches positive infinity, so as we go to the right on our graph, our right half is going up, so it's going to positive infinity. And as x goes to negative infinity, the left half of our graph is also going up, so it's going to positive infinity. We're going to skip number 4, and I want you to do number 4 on your own once we do number 5. So if we look at number 5, our degree is going to be 4. That's the highest exponent. Our leading coefficient is -1 because of this negative in front. Our turning points, we're going to have 1, 2, 3 turning points. And then as x approaches infinity, so if we go to the right, our graph is going down, so it's going to negative infinity. And then as we go to negative infinity, our graph is going down also. So we're also going to negative infinity. All right, so looking at number 6, the degree of this would be a 3. The leading coefficient, it's just a -1. And the turning points, so we switch directions 2 times, so we have 2 turning points. And as x goes to positive infinity, our graph is going down, so we're going to negative infinity. So as we go to negative infinity in this direction, our graph is going up. So we're going to have negative infinity to positive infinity. All right, do number 4 on your own. So pause the video, do number 4, and make sure that's complete. As roots, zeros, or solutions. So this usually you can only see, and when I say usually, I mean always, you can only ever see your x-intercepts on your graph if they're real solutions. Anything imaginary you won't be able to see on your graph. So solutions are either x equals a number or given in set notation. So it might look something like 3, 4. So when writing equations for a graph, we want to consider end behavior, degree, and behavior at our intercepts. So when it asks you for an equation, you want to write that in factored form. All right, so let's look at number 7. So solutions, that's going to be anywhere we touch the x-axis. So we have -3, -1, 2, and 6. And so now we're going to write our equation. And what we want to do is we want to figure out what our leading coefficient is and what our degree is. So just looking at the graph, since both ends are going up, that tells us that our leading coefficient is positive. And since both ends go in the same direction, then it's going to be an even degree. So now we're just going to write this. When we write in factored form, we switch the sign. So if our 0 is x minus 3, we're going to write it as x plus 3. And we just cross right through the graph, so that means it has a multiplicity of 1. And all of these are actually just crossing through the graph, so we don't need to worry about exponents. So we have x plus 1, x plus 2, and that would be x minus 2, x minus 6. All right, and then I want you to try number 8 on your own. Don't forget that when you have a bounce like this, that means you're going to have an exponent of 2. So I'm going to go ahead and set it up like that so you know kind of what to look for. And the leading coefficient on this one, since the right end goes down, your leading coefficient is going to be negative, so don't forget about your negative. So write your factors, write your solutions on your own, and then just make sure you use this framing. All right, if we look at equations given zeros, if c is a 0, then x minus c is a factor. So what we're going to do is we're going to write all of our zeros as factors and then multiply. So I'm going to write this as y equals x plus 4. We have an x. And we have an x minus 6. So when you have just a solo x like that, we want to put it out front. All right, and then we're going to multiply. So I'm just going to focus just on these two functions, or these two factors first. So I'm going to FOIL. I'm going to do x squared plus 4x minus 6x minus 24. And we'd still have that x out front, equals x, and I'm going to combine like terms in the parentheses. So x squared minus 2x minus 24. All right, and then we just distribute that x in, and that should give us our equation in standard form. So it would be x cubed minus 2x squared minus 24x. All right, for the next one, we're gonna write this one in factored form first. So whenever it says to write an equation in standard form, we always write it in factored form first. So we're gonna write y equals x minus 1/2 x plus 5. So we never want a fraction to be written like this. So what we're gonna do is we're gonna take whatever's in the denominator, and we're going to take that 2 and put it in front of the x. So we're going to rewrite it as y equals 2x minus 1 and x plus 5. All right, and then we just FOIL that out. So I'm going to have 2x squared minus x plus 10x minus 5. And then we just combine like terms. So y would equal 2x squared plus 9x minus 5. All right, increasing and decreasing intervals. So always, always, always read your graph from left to right, just like you would a book. Make sure you only use the x coordinates when listing your intervals. So we only ever use x values to write increasing and decreasing. So if we look at this one, let's just start from the left of our graph and see what happens. So if we trace our graph from the bottom, so let's just trace our graph and see what happens. So if we trace our graph from the left, that's where our graph starts, and then we stop increasing. So this part of our graph, we'd be increasing, and we're going to write that from negative infinity. Think about your x-axis. We go from negative infinity to that -2. All right, and then we're going to start decreasing at that same point. So we're going to go down. So from -2, that same x value, to 0. So remember, we're thinking about it in terms of x. That little green section is decreasing. And then when we get to this portion, we're increasing again. So for the rest of the graph, we're increasing. So we would put union. We'd start up again at that 0 point, because that's where our graph starts increasing again, and it goes until positive infinity. All right, make sure you finish the questions that we didn't completely do together, and then take your